Hello everyone, this is Mr. Appel, and today we are going to finish up our prerequisite unit on solving equations. We're going to focus on radical equations, equations with radicals in them. Radical equations. Radical, dude! Alright, here we go. Let's look at our first example. Here we're seeing one you may or may not have seen before. We've actually got radicals on both sides of the equation. But as you'll see, not going to be a problem at this point. So first of all, we want to look at the domain. Remember, with radicals, what causes problems for the domain? What causes problems is if you have a negative under the radical. We're looking for real solutions. So any x values that would make what's underneath the radical negative will cause a problem and would be excluded from our domain. So we actually have to worry about two situations. We have to worry about what would make that be less than 0, and what would make that be less than 0, and then kind of combine those two things together. So what we're going to do is try to find all the x values that do work. And again, what I'm looking for is what's going to keep what is underneath the radical to be non-negative, or an easier way of saying that is what will make it be greater than or equal to 0. So what I'm going to do is I'm going to say, okay, x plus 4 greater than or equal to 0. I'm going to find the x values that make that true. So I'm going to have x greater than or equal to negative 4. So those are all numbers that work. And if you see by plugging in, again, just focusing on the left side here, if you plug negative 4 in, negative 4 plus 4 is 0, no problem. If you plug in anything bigger than that, like let's say negative 3 plus 4 is 1, no problem. But if you pick something that's not here, like negative 5, you'd have negative 5 plus 4, which is negative 1. Square root of a negative is imaginary, and we'd have a problem. So this is the first part of a domain. Then we need to worry about the other part of our domain. So we're going to do the same thing there. So 6 minus x has to be bigger than or equal to 0. So if we solve that, we'll add the x to both sides. And if it helps you to flip that around, we've got x is less than or equal to 6. So notice that the values that work are these that are bigger than or equal to negative 4, and these that are less than or equal to 6. So it has to meet both constraints, because if either one of these blows up, the equation blows up. So our domain is just the numbers that meet both of these. So this is an AND situation. And so we'd have all the numbers, all the real numbers from negative 4 to positive 6, including those endpoints, so that's closed brackets. Okay, now let's go ahead and solve this equation. Well, this one's already set to go because they're radicals on both sides, nothing else going on. We'll talk about some other examples in a minute. So we're going to go ahead and square both sides of this equation. Perfectly legal move. Squares and square roots cancel out, and we're going to be left with a very simple equation, which is that. And if we move the x's over and move that over, we end up with x equals 1. With radical equations, now you always have to check. You have to check your solutions, and you'll see why in just a minute. So x equals 1, 1 plus 4 is 5, so the left side would be the square root of 5. So I'm checking to see if that's going to equal 6 minus 1, so that would be the square root of 5. Sure enough, it works. So x equals 1 is our solution. Great, let's look at another one. Let's try. Okay, so this one, again, the domain, anything that's going to keep what's under the radical non-negative. So I'm just going to do x plus 5 greater than or equal to 0. So x must be greater than or equal to negative 5. So my domain is all real numbers from negative 5 to forever. So we write it in interval notation like that. Now let's go ahead and solve. Again, you want to isolate the radical, which already has been done for you here. But sometimes that'll require a couple of steps, and I'll show you that momentarily. So I'm going to go ahead and square both sides of the equation. Over on the left, the radical and the squaring cancel out. And over on the right, you got to distribute there. That's x plus 3, so that's x squared plus 6x plus 9. And now we've got to solve this quadratic. So we're going to set it equal to 0 and see if it's factorable. So I'm going to move the x and the 5 over. So we're going to have x squared, 6x minus x, that's plus 5x, 9 minus 5, that's plus 4. And I see that's an easily factorable one, so I'm going to go ahead and solve that by factoring. So that's 4 and 1. And so x equals negative 4, x equals negative 1. Now I'm checking to see, first of all, checking to see that those two numbers are in my domain, which they are. Negative 4 and negative 1 are both in that domain. They're both bigger than negative 5. And I need to check to make sure that they actually work. So what I'm going to do is, where's my tool here? I'm going to plug back into the original equation. So negative 4 plus 5 is 1, so square root of 1 equals negative 4 plus 3. Negative 4 plus 3 is negative 1. Wah, wah. It didn't work. What? But we did everything right. What happened? Well, with radical equations, this can sometimes happen, and it's called an extraneous root. And you got to write that down. You need to know this. It's called an extraneous root or an extraneous solution. Basically means a solution that algebraically you get, but it doesn't actually work. And this is just kind of a quirk that happens with radicals. We can get more into why that happens a little bit later, but it does happen. So that's an extraneous root, so we have to actually reject that possible answer. And what I like you to do, I'm going to erase some of that to make some room, is to actually label that, and just so that I know why you cross it out. You can abbreviate. Whoops. You can abbreviate and just say EXT for extraneous. And that's why I know why you crossed that out. Now let's go ahead and try negative 1. So if I put negative 1 in, I get negative 1 plus 5, which is 4. So I get the square root of 4 is equal to negative 1 plus 3, which is 2. And that is true, so that one works. So our solution is just x equals negative 1. And that's all for now. We'll see you tomorrow. Have a great day.